In this video, we'll look at the difference between black box testing and white box testing. We'll look at how to create a black box test plan based on input ranges, and we'll look at different forms of test coverage in regard to white box testing. This is an important thing to keep in mind when you're testing. A good test is one that has a high probability of finding an error. You can't test a program with every single possible input, so you have to choose test cases that are most likely to find an error. The most likely place that errors occur is in boundary cases. For example, if you're testing a stack component, you might test the behavior of an empty stack, a stack with only one element in it, and a stack with more than one element in it. If a stack with 4 elements has a problem, it's likely that a stack with 3 elements will have the same problem. But a stack with no elements might be handled differently by the implementation, because the empty stack is a boundary case. And a stack with only one element in it is close enough to the boundary case that it should probably be tested as well. The objective of test case design is to try and uncover as many errors as you can, hopefully all of them, in as little time and with as little effort as you can. Writing test cases takes time and effort, so you don't want to spend your time writing a lot of redundant tests. There are two main kinds of testing for a component: black box testing and white box testing. In black box testing, you treat the component like a black box. In other words, you can't see inside the component to its implementation. The only information you have about the component is its specification. That is, the description of what the component does. For example, the specification of a Java class would be its API, the Java docs. That's why black box testing is sometimes referred to as specification-based testing. In white box testing, you do have access to the implementation. And part of your goal in white box testing is to cover all of the code in the implementation. We'll talk about what that means later in this video. The concept of a test case is fairly straightforward. Given certain input, we need to ensure that we get the expected output. The output value we expect is called, not surprisingly, the expected value. And the value that we get from actually running the code is called the actual value. When the actual value equals the expected value, our test case passes. Note that it may not be enough just to check the return value of a method. If a method has a side effect, for example, we'll also have to check if the actual value of the object affected is equal to the value we expect. Another thing to notice is that the value we are expecting is based on the specification of the component. This is true even when we are doing white box testing. White box testing still has to test actual values against the values we expect based on the specification. But it has the extra responsibility of covering every statement in the code. In black box testing, we don't look at the implementation of the code. We simply develop our test cases based on the input of our operations and the expected output. As we stated earlier, we cannot test every possible input, so we have to make some smart decision as to what test cases to write. In black box testing, we choose these test cases based on the range of our inputs and the boundary values in that range. For example, if our input includes an integer that can go from 0 to max int, we might test inputs 0, 1, and max int. 0 and max int because they represent the beginning and end of our range, and 1 because it also represents a boundary point. It's the multiplicative identity. In white box testing, we don't focus on boundary points of the input range to get our test cases. Instead, we focus on generating test cases that will cover every statement in the code. This slide gives some good reasons why you might want to do that. The first item says that errors are more likely to occur in code that is not executed as often. That makes sense, since a developer is typically thinking about the common case which he or she is creating the code. The second item is saying that code that we think might only be executed rarely might turn out to be executed quite often. Though this item may be true, we want to make sure that we test all code, regardless of how often it'll be executed. Finally, you can make a typo in any statement, so you should test them all. It turns out that statement coverage is a fairly low bar for testing. When you see statement coverage referred to, it simply means that your tests have to cover or execute every line of code. Branch coverage refers to covering both branches of a condition, the true branch and the false branch. And path coverage refers to covering all possible paths through a given program. Let's look at this in some detail. Suppose we have a method called getResult that takes two Boolean arguments. It returns 0 if both conditions are true or if both conditions are false. If the first condition is true and the second condition is false, the method returns positive 1. If the first condition is false and the second one is true, the method returns negative 1. You should be able to convince yourself that this is a correct implementation of this method. X starts out as 0, and if both conditions are false, X is not modified, so the method returns 0. If both conditions are true, the modifications to X cancel each other out, and again, the method returns 0. If only condition 1 is true, X gets incremented, and the method returns 1. If only condition 2 is true, X gets decremented, and the method returns negative 1. Now let's write a unit test case for this method. The test case given here will pass. The question I have is, what will the coverage look like? In common test coverage tools like ECL-EMMA, there are 3 levels of coverage for a line of code. The first level is green, meaning that line of code was executed or exercised during the execution of your test. The next level is yellow, meaning that the line of code contains a condition and only one branch of that condition was executed. All conditions have 2 branches, a true branch and a false branch. If a line of code is yellow, one of those branches was never followed. The last level is red. Red means that your test cases never exercised the line of code at all. So my question to you is, what are the levels or colors of the 4 lines of code in this method? If the only test case that is run is the one given here. I'll give you 10 seconds to answer this question, starting from now. Ready? The first thing to notice is that all lines are executed. In other words, there won't be any red lines. However, both lines with conditionals will only have one of their branches followed, the true branches. That's because we're passing in a value of true for both conditions. Since coverage tools like ECL-EMMA color the background of the executable lines after the tests are run, the result would look something like this. Though a statement is not the same thing as a line of code, when people say statement coverage, they typically mean line coverage. In this example, the code would have 100% statement coverage, but it would not have 100% branch coverage. To get 100% branch coverage, both branches in all conditions would need to be covered. In our case, there's an easy solution. Add a test case that exercises the false branches for both of these conditions. And this is what that would look like. we simply pass in false for both arguments. Since condition 1 equals condition 2, the expected result is still 0. So this is wonderful. Both of our test cases pass, and we have 100% statement and branch coverage. Unfortunately, there's still the potential for problems here. Since all of our test cases pass and we have 100% coverage for statements and branches, you might feel comfortable concluding that the given code is correct with respect to its specification. Note here that I'm calling the description above the code its specification. And in this example, you would be absolutely right, because the code does happen to behave correctly in all cases. However, I could give you another example where these exact same test cases pass and where I get 100% coverage of both statements and branches, but the code is not correct. Now, I would have to change the code to do that, but I wouldn't have to change it a lot. In fact, I claim that I could change a single character in this code and still have both test cases pass and still have 100% coverage, and yet the code would not be correct. Please pause the video and see if you can figure out which character in this code you would change to get incorrect code without changing the test results. Ready? Okay, I said you could do this by changing only one character, and that character is X. Instead of returning X, we simply return 0. Notice that both of these test cases have an expected value of 0. So if we always return 0, both of them will pass. Furthermore, the code coverage hasn't changed. All of the code is still covered. However, when only one of the conditions fail but not the other, the expected result is 1 or -1, depending on the conditions. But the actual result will be 0. Therefore, this code is broken.